Hello guys, welcome back to the channel. This is Rosario Borgesi and today we will discuss how to create an Ethereum wallet with MetaMask, how we can send and receive Ether, how we can swap between the many tokens that are present in the market, and how we can bridge the token from one chain to another. And we will discuss what are the different types of tokens that are present in the market, and what are the different Ethereum layer, like layer 1, layer 2, that are present today in the Web3 world. So there is a lot to cover, but let's get started. Understand what are Ethereum wallets, what is a public key, a private key, what is an account. Let's start by creating a new Ethereum account on Ethereum with the MetaMask, and then we will understand all this other stuff. So this process will be done on Chrome. On Edge, but it is the same also for Chrome and for Mozilla Firefox. So we install MetaMask. Okay. Extension. Okay. Here we have Mozilla. Here we have MetaMask. We create a new wallet. Agree. Create a password. This password is not related to the account. It is just used to Mozilla to access the account in an easier way. Here we create the wallet. Okay, here is telling us to save the 12-word phrase, because the 12-word phrase it is what allow us to access our account, and this should be kept private. But since this is a wallet that I will not use apart from this video, I will not use this wallet anymore. I will show you the private key, but you should keep it private. Write it down on a piece of paper, or you save it in a safe place, because if someone gets your private key, your 12 words secret phrase, they can access your wallet and get all your funds, all your money. So okay, reveal secret recovery phrase. Okay, this I copy to the clipboard. I copy it on notepad. Okay, these are the 12 words. I repeat it. Be careful, store it in a safe place. Do not ever share them with anyone, because if someone gets your 12 words, your seed phrase, they can get all your funds, all your money. So next, here it asks me to put the missing words to make sure that I have saved them. Okay, then the fourth is behave. Okay, then 7, 8 is cage. It should do. Got it. The wallet, it has been created. Next. Okay. Enable. Okay. Okay. So now we have our wallet, and as you can see here, we have an account, and this is our address, the address of our account. This is the public key. Okay, we copy it. Okay, and also this account has a private key that we can access here. Also, the private key should never be, like the seed phrase, should never be shared with other, because otherwise other people can get access to this account. Show private key. I use the password I have created before. Okay, now this is my private key. So this is the address, and this is the private key. Right. Okay, beautiful. And this is the address or public. Okay, done. Let's see what it has happened with draw your graph. So here we have created an Ethereum account. So here we have an Ethereum account which is with this seed phrase. Okay, so the seed phrase, it is used to create a new Ethereum account, and it can be used also to restore an Ethereum account. So this is the this is the reason why we should never share the seed phrase. But inside, sorry, this is an Ethereum wallet, which is a MetaMask wallet. But inside an Ethereum wallet, we can have multiple accounts. Okay. So for example, we have created the account 1, which has this public key, okay, let's make it larger, and it also has a private key. Sorry, this is public. Okay, and this is a private. Okay, the private key is this one. So private key, it is used to sign the transactions, and this, as we said earlier, let's see if I can change the color. Okay, I changed the color into red. Let's see that also this one, I make it red to make remember that this should never shared with anyone. Okay, so with these 12 words with the seed phrase, we have created this account here. But we can also create multiple accounts from the same Ethereum wallet. Okay, so for example here I can say add an account, add a new account 2, create. Okay, here it has created a new couple, a new private public key pair. So this was account 1, this is account 2, public key is this one, and we can also get No. We can also get the private key. Okay. I save it here. Okay, so we now have created a second account from the same wallet. The public key is this new one here, and the private key is this. So we can create from our wallet an infinite number of accounts, but all these accounts are not related to each other. So for example, this public key, this private key has nothing to do with this public key, and vice versa. So only this public key is related with this one, and this public key is related with this one. Sorry, this is account 2. Why this is important? It is important, and also if we want to, for example, if we have money, for example 1 Ether, if this account has 1 Ether, let's put it in which is the currency of the Ethereum blockchain, the native currency. This account, the second account, knows nothing about the previous account, and vice versa. So there is no way that these two accounts can connect each other, but we, for example, here in MetaMask, by means, as we will see later, of the send function, we can send money from one account to another. Okay, so we can send money from this account to this one, but they are not related, they have no connection. This is important because if we use for privacy reason, also for security reasons, sorry, for example, if we want to use a site that we do not trust, and for example to mint an NFT or whatever for DeFi, whatever we want to do, we should never use the account where we have all our money, our funds, but we should create a second account and use with lesser money and use this one. So this allows us to take less risks. For example, here, let's say that we have 1 ETH, all our funds in the first account. We use the second account. Sorry. Here we have, for example, 0.001 Ether. Okay. Let's say that we use this account, for example, to use in a new website that we don't know. For example, we use in a website malicious that we don't know. Okay. And we, for example, mint an NFT, they create a malicious smart contract. They can install only our 0.001 ETH. They cannot get, sorry, here I had 1 Ether in the first account. Okay, so if they get access to this address here, they can never get to the funds, to the money that we have in the first account. So it's always a good practice to use another account, also called the burner account, burner wallet, burner account, sorry, to with the website that we don't know, in order to preserve the money that we have in our most important account. So always use a burner account to interact with new websites, for example, to mint NFTs or of websites that are new, that are not known, and never use your main account. So this is important for security reason. Also, never, I will repeat it again, never share your 12 words seed phrase or your private key of the account, because if they can get to these 12 seed words, they can get access to all your accounts. If they get access to the private key of your account, they can only get the funds of this single account. So this is the difference, which is very important. So now that we have understand how Ethereum wallet, what are Ethereum wallets, what are the accounts. Sorry, I forgot to say, this public key, okay, of our address can be shared with other in order to receive money. For example, here, from my account, I can use this address here and give it to someone to receive Ether, so to receive a token. Okay, so also, for example, here, if I touch this, if I press this button here, this QR code, you can send money to my account. So it is there is no problem in sharing your public key, this one, but you should always keep private the private key, which you can get here as we have seen earlier. So this should never be shared, while this you can share it with anyone. Okay, this is important. And another thing that I want to talk about, which is very important, I want to recall some basic information about the blockchain and layer 2s, because they will be useful for the transaction that we will see later. So, for example, here I create a new page. Okay, let's recall that recall what it is a block. Okay, let's write, for example, John writes, sends 1 Ether to Alice, Jack sends 0.1 Ether to Janice, and for example, Rob sends 0.5 Ether to Paul. So this is an example of a block in a blockchain. Okay, so you have basically you have a register of transaction. What a block contains the single transaction that have been executed in the blockchain. So, for example, John sends 1 Ether to Alice. Sorry, this should be capital. Jack sends 0.1 Ether to Janice, or Rob sends 0.5 Ether to Paul. These are all examples of single transactions that are included in a single block. Then in a blockchain we have multiple blocks that are connected together. Okay, for example, here we have other transaction. For example, Jack sends 1 Ether to I don't know, Mario, sorry. Also, for example, Andrea, let's say, that sends 2 Ether. For example, Andrea sends 0.7 Ether to Jennifer. And also Elon sends, for example, 5 Ether to Jasmine. Okay, this is another block. Imagine having a lot of this block with this transaction that are connected together. So this is they form the blockchain. So for example, let's add some text here. Let's say this is block 1, block 2, block 3. So this is the blockchain, basically how the blockchain works. Let's maybe reduce these boxes here so it is can be seen now more. It is better on the screen. Okay, this is what it is, a blockchain. Okay, so here there are, for example, block 3, other example of transaction. For example, Joseph sends I don't know 3 Ether to Jack, or Andrea sends 50 Ether to I don't know, Carol. And also here you have Paul that sends I don't know 1 Ether to Mary. Okay, so a blockchain, it is a list of blocks that are connected together. Each block connects to each block connects to the former block, and so on, in an infinite chain. Okay, but there is a problem, because this is how works, let's say, the Ethereum mainnet. Ethereum mainnet. And mainnet. Okay, let's say that in this mainnet, let's say that after it has been created by Vitalik Buterin, the transaction became too much, and they were too expensive to hold all the transaction on one chain. So they decided to create a layer 2, which is basically a parallel blockchain. I make it smaller here so you can understand better. And the layer 2 is basically a layer that let's say it is somehow connected to the main network, where there are the transactions are not executed on the mainnet, because they here cost a lot of they are more expensive in the layer 1. So let's say Ethereum mainnet layer 1. Let's make it bigger. Okay, This is the layer, also this capital letter. This is the layer 1, and it has been created various layer 2. This we can make it smaller. No. Okay, where the transaction are not executed. Some transactions are not executed here, but are executed in this second layer, which is a parallel blockchain, in order to have lower costs. And this way, the main net of Ethereum could scale, so could support more transactions. So, for example, let's say that in a block there are other transactions like Jasmine sends 1 Ether to Rob, or for example, and this transaction, let's say that we put, instead of executing it in the layer 1, we put it here in the layer 2. Okay, then we also, here we can have other transaction. For example, Jack sends I don't know, 0.5 to Joseph, or also here Carol sends 1 ETH to Rob. So it is another blockchain parallel to this one. In this way, here in the mainnet we execute fewer transaction, and we can execute other transaction in a blockchain that is parallel to this one, and this way we can obtain scaling, and also this layer 2 have layer fees. There are various example of layer 2s. Let's say there are, for example, Optimism. There are Optimism, also Arbitrum. There is also another chain called layer Polygon, and Polygon, and there is also, for example, Base, which are among the other the most known. So there are, imagine that there are others layer 2 like this that work in parallel. Okay, don't like this, sorry. Okay, so we have multiple layer 2. This could be, for example, Arbitrum, and this could be, for example, Base L2. Each one that performs different transaction. For example, here Barak sends 3 Ether to Jasmine. Here Rob sends 2 Ether to Francesco, to Frank. Or also here Jack sends, here was Barak. Jack sends, for example, Jack sends, for example, 2 Ether to Kyla. I don't know. So we have multiple layer 2 that are parallel to each other, and so the layer 1 executes its own transaction, layer 2 its own transaction, layer 3 and the other layer 2 their own transaction. But why there are all these layer 2? Because each one has its own rules for consensus, and they should be they work with their own rules, which may be which are different from the layer 1. So this is the basic difference between a layer 1 and layer 2. So another thing that is important to bear in mind is that the main currency of let's add another text here. The native currency of all these layers is always Ethereum. Okay, so this is the native currency of all of these layers, but each layer but there are also the tokens. You have for example seen, you can go for example on CoinMarketCap. Okay, here there are on Ethereum, let's say that we want, here are listed all the tokens of various blockchain, but for example USDC is another token that you can see on Ethereum, or for example Chainlink is another token that you can see on Ethereum, or USDT. Okay, what is the difference between the native currency and a token? So let's open another page here. So we have said that Ethereum comes with its own native currency, which is Ether. Okay, but there are also other tokens that we can trade on Ethereum, for example USDC, for example USDT, or for example I don't know, there is also maybe other token like for example Uni. This is by Uniswap. This is called the Uni. This is another token. Okay, for example Uni or Optimism. Let's talk for example what are all these. There is the chain Optimism, but there is also for example the token Optimism. I can find it here, for example Optimism here. Okay, OP. Okay, OP. So we have the chain Optimism, which is a layer 2, but we also have the token, which is OP. And the native currency of Ethereum is Ether. Okay? What is this difference? Also, these are all examples of ERC-20 tokens. I put it here. ERC-20 tokens, which is a standard. You can learn more about this in another video that I've done in my channel. Here I discuss I have discussed the ERC-20 tokens. ERC-20 tokens are basically tokens that where each token is identical to another. Okay, but they have some like for example the one that we have listed here, so USDC, USDT, Uni, OP. Okay, and they have some properties because these are smart contracts. Okay, So it is code that is executed on the blockchain. So it is different. So while the blockchain was born with Ethereum was born with the ethers, so ETH, and it is the currency that used to pay the gas fees or also send the ethers between to execute transaction. These tokens here are ERC-20 tokens, which are smart contracts. So it means that it is code that it is executed on the blockchain. And so they have these properties, for example, name, symbol, decimals, okay, they have some functions. So for example, here, when you want to transfer an USDC from one address to another, you behind the scene you are calling the transfer function, okay? Or for example, if you want to know the balance of a user, you are calling this function here a balance of the contract. For example, in this case, USDC that is deployed on the blockchain. For example, if I look for USDC contract on mainnet, okay, here you can see this is the Ether scan, where you can check transaction, smart contracts and so on. Here there is the token USDC, okay, you can see this is a contract, a smart contract, so there is code here, okay. You can find for example here all the function that we have talked about earlier. I don't know, there must be inside here, okay, but it is a smart contract, okay. So this has an address, which is this one. So we are calling this address when we are performing the operation of transfer, balance of, or whatever. So it is not the currency here that it is like this one that is moved from an address to another, but it is called the smart contract that moves the balance of the token from one address to another. And here on CoinMarketCap you can find all the tokens. So for example, to have there are also other examples of token. For example, you cannot have Bitcoin on Ethereum, because Bitcoin and Ethereum are two different blockchains, but there is a token called, I don't know why I can't find it here. There is a token called Wrapped Bitcoin that it is an ERC-20 that basically it is on Ethereum. It is an Ethereum token, so it is a smart contract, but follows the price of Bitcoin. So you can, for example, invest on Bitcoin on using an Ethereum, because as we know, Bitcoin does not have the smart contracts. And there are also other examples. For example, there are also other, as we said, the Chainlink. Chainlink has its own token, which is Link, and you can use it on Ethereum. The important thing to understand is that there are also other tokens. I don't know, there are also, as we saw earlier, the Uniswap token. Basically, then each layer 2, like for example Optimism, Arbitrum, or Uniswap, or also Polygon, creates its own token in order to get so they can finance themselves, but they are two different things. The token from the chain are two different stuff. So coming back to what we were saying before here, you can have, for example, I would like also to say that USDC, these tokens, USDC and USDT are, as we said, ERC-20, so they are smart contracts. So smart contracts, and they are called. So let's write are ERC-20. They are smart contracts, and also they are called stable coins. Stable coins means that their value is pegged to the dollar. So for example, 100, you can see here, no? For example, if I take USDC, 1 USDC, its value is pretty much $1. The same is for USDT, Tether USDT. One Tether, one token has a value of exactly $1. So these are called stable coins because their value is they keep their value fixed. While for example wrapped Bitcoin that we have seen earlier, this follows the price of Bitcoin because now it is $94,000. Okay, and it has a price that changes over time. So you can see, for example, all here it was for example $1,000. Now it is 94,000 because it follows the price of Bitcoin. There are also other types of tokens, but this is what it is important. I want also to say that these tokens, all the ERC-20 tokens, since they are smart contracts, we can have them in all either on layer 1 but also on the other layer 2. So for example, I can have on layer 1, I can use USDT also here, I can use USDT also here, I can use USDT also here. The same also holds true for USDC. The same here you have also USDC, and here you also have USDC. So if I want to move a token, either USDT or whatever, from one chain to another, it means that I am doing a swap, a bridge operation, because I am moving the funds from one chain to another. While if I, for example, on the same chain exchange Ether for another token like USDT, it is called a swap operation. And so the only thing that changed, while Ether Ether does not have a smart contract because it is the native currency of the chain of Ethereum. So Ethereum mainnet layer 1 has Ether, layer 2 each layer 2 has always Ether. USDT, for example, it is a smart contract. So if we call USDT on the mainnet, we have this address here. So let's add this thing here. So USDT on the mainnet is a smart contract that has this address. Okay, perfect. If I want to interact with the USDT on a layer 2, the address is not the same. It is another address because the smart contract it has been deployed at another address. So for example, if I search USDC on, for example, this is Arbitrum. USDC on Arbitrum mainnet. Okay, here there is another scanner which is Arbiscan, because the Arbitrum, it is another blockchain layer 2. I said USDT. Sorry, what was that? I don't know if I... Let me second check. Allora, so let's look for USDT contract on we said Ethereum mainnet. Okay, this is USDT. Tether USDT stablecoin Etherscan. Okay, is this one? Okay, this is the address of Tether USDT. So it is maybe I copied the USDC. Okay. Now here I'm looking for Tether on Arbitrum mainnet. No, USDT on Arbitrum mainnet. Arbiscan maybe. Okay. Okay, this is the address of the token. Okay, so here as you can see, the address of USDT on Arbiscan is different. WB9. Here I have WB9. Why? Because it is a smart contract. Here on Base, for example, if I look for Base mainnet USDT base scan, as you can see, each layer has its own block explorer, which is different. Here I look for USDT, Tether USDT. Help me. USDT Tether USDT. No. Tether USDT. Tether USDT address base mainnet. No, this is Etherscan. Base scan. Base scan. Base scan. It should be this one. I am not sure is this one, to be honest. Tether base mainnet. There is not enough information. We need to it must have an address. Tether USDT on base mainnet. And maybe it's not available right now. mainnet ether scan. I don't know if it is already available on base. Maybe it is not available on base mainnet, but it will. The point is it will have its own address, which will be different from here. So while with Ether we do not have different addresses because it is not a smart contract. For the ERC-20, like USDT, USDC, or whatever token they create, they need to deploy a new smart contract, and we interact with that smart contract that will change for each, we change address for each chain. And so let's see some practical example. This is an account that I have on MetaMask, and let's try to swap a part of this token USDC into the link token, which is provided by Chainlink. So I go here on swap, I select USDC, then here I select link. Okay, then I want select the amount I want to exchange from USDC to link. For example, let's say 18. Let's say 20. Okay, it will give me 1.10 link tokens. So as you can see here, it provides us also the fee that we have to pay for this operation, the estimated fee. We are on the Ethereum mainnet, so it will cost more, and so we execute this swap here. Remember that in each Ethereum transaction we have to pay the fee because this is a distributed transaction. So let's okay, the transaction has been confirmed, so here I can close. The swap has been completed. Okay, so now I have 1.10 link token, and the amount of USDC has been reduced to 10 USDC. Maybe it is better to change. No, maybe it is better to change the currency in euros, in USD. Okay, perfect. And now we can also, for example, convert an amount of USDC into Ethereum, into Ethers. So for example, we can execute again the swap operation. We select USDC, then we select the token that we want to convert the USDC to, which we can say, for example, let's see what happens with 5 USDC. It will give me, okay, 0.001 Ethers. Let's say I want to convert all of my USDC into Ether. Okay, this is what I will get with this quote. I execute the swap. Okay, so now it is executing again the operation. Okay, so the swap has been completed. So now I have 0 USDC and I have an higher amount of ethers in my account. I can, for example, also perform a bridge. So while swap means to exchange one token in another in the same chain, so I have always been on the Ethereum mainnet and I have not changed the chain. In this case, I can also perform a bridge, which means to move the funds from one chain to another. For example, here I can move my Ether to another chain like a layer 2 like base. For example, we can press here bridge. Okay, it will open this new page here. So we can select the starting chain, which is Ethereum mainnet, and we want to go to base. Okay, I want to send, for example, ethers 0.001, for example, and I receive here also ether. Here is calculating the best price for the bridge. As you can see, here we can also perform if we press this button, we can perform the bridge operation. Okay, now I accept and I confirm. Confirm. Okay. Here it asks me to confirm the transaction. As you can see, there is always the fee to pay in Ethereum. And in every blockchain, you always have to pay the fee for the transaction. Now we wait until the transaction is complete. Okay, perfect. So now we should see that if we go to base network, base mainnet, let's add this new chain. Okay, I have 0.001 ether, so it has moved the funds from the Ethereum layer 1 to base mainnet, which is an Ethereum layer 2. If I come back to my account, I can see here all the history of the transaction, the swap that we have performed, the first swap from USDC to Link, the swap from USDC to Ether, and also the bridge of Ether from layer 1 to layer 2. We can also, for example, here there are also all the information. As you can see, we have paid a lot of money to transfer to perform, for example, this operation. This is because the layer 1 it is very expensive, so we can also, for example, check the transaction on Etherscan. We have all the information here that we can check out. And for example, other operation that we can do, for example, we can receive money, for example, in this account. This is the address that we, for example, can provide to another to an exchange, like for example Binance or Coinbase, to transfer the money from Coinbase or Binance to our account MetaMask. We just have to provide this address, and the funds will be sent to our wallet. And we can also send the money to another account. For example, if I want to send the money, ETH or whatever token, to another address, I can click send. For example, I can send the token to my second wallet, let's say an amount of really low ethers. This is my second wallet, but you can send them to whatever wallet. You can choose whatever token you want to transfer from an account to another, and you just press continue. As you can see here, there is always a fee to pay, so I can confirm. Okay, and this is sending the Ether. Okay, the transaction has been completed. If I go to my second wallet, which is this one, I can see that I have this very very few Ether that have been sent before from my account 1. We can also check the transaction here. You see that in the layer 1, for a very small amount of Ether, I have paid almost $1. So you can understand why this the layer 1 is not very useful to perform this operation, but it's more convenient to use layer 2 like Base or Optimism or Arbitrum or whatever, or Polygon, where the gas fee are lower. So that's it for the mainnet. But since we are developers, we can do also this stuff in testnets. So for example, here we have the Ethereum mainnet, but we also have the testnet, which is for example for Ethereum Sepolia. Okay, here the Sepolia Ethers are fake money, are not real. And as you can see here, MetaMask does not allow you to perform swap or bridge, but you can send money to other account like we did previously. So one thing that is important is that in order to get the Ether in the testnet, you need to make use of a faucet. for example, this is an example of Faucet, which is Chainlink. You can select here, for example, Ethereum Sepolia. It will give you 0.5 ethers. You select continue. This is my account because it has already been connected. Okay, we verify, we select get tokens. Here we have to confirm obviously the operation. Here this token works only if you have one link on Ethereum mainnet, which we have because we have performed earlier the operation, so we can make use of this token. Here is the transaction hash. As you can see here, the block scan is different. Previously was Etherscan for mainnet, now it is Sepolia Etherscan for the testnet. So the transaction is pending. We can pause the video until it has been done. Okay, the transaction was successful. So here we can see all the... they have given me 0.5 ether, Sepolia ether, and we can find it here. So if we go to Sepolia testnet, we can find that now I have 5.5 Sepolia ether. It is also possible, for example, to get a faucet for there are also testnet for layer 2, for example for base. There is a base Sepolia here. For example, we can also here get money for base Sepolia with a faucet. Base Sepolia faucet. Let me close all this. Okay, here is the Coinbase developer platform faucet. Also here, as you can see, it requires that we have at least 0.001 ether on Ethereum mainnet. So here we can do this is my account. Okay, I can put this here, claim. Okay, and now I have it has been given 0.1 ether on my here on my base Sepolia testnet. It is also possible to perform also here a bridge. For example, if you have all the money on Sepolia, you can for example use a bridge base Sepolia. Okay, base Sepolia bridge testnet, for example this one, super bridge. Okay, this is Sepolia. I'm going to base Sepolia. I want for example 0.1 review bridge. Okay, continue. Understand. Okay, continue. Start. Here I always need to confirm the transaction and to pay the fee, as always. So we wait 3 minutes, I pause the video, and then we will see that the transaction has been performed. Okay, our transaction has been performed. So here if we go on base Sepolia, we can find that our but the balance, the Ether balance should have been increased because we have performed the bridge. And we cannot see very well because it was a very low amount of Ether, but it has been done. So another thing that is important to know is that to swap token in the testnet, it's hard, and I don't know if it is really feasible. But for example, if you want to use USDC on testnet, you can use the circle faucet. So on the testnet, you can bridge ethers, but to perform swap, I don't know if it is feasible, but it is very rare. So for example, here I put my address, which is this one, and it will give me 10 USD. The circle faucet will give me 10 USDC on Ethereum Sepolia. Okay, and I can see this here. I need to change the network, which is Sepolia. And if I go here, this is the bridge that we did before to transfer the money from Sepolia to Base Sepolia testnet. Here I go on tokens, and here I don't see the USDC because we need to import the tokens. So we can do it this way. We look for the USDC contract on Sepolia. USDC on test network here. So this is the contract that we are looking for, because remember, while Ether it is the currency of the chain, the token, an ERC token like is USDC, it is a smart contract. So when we transfer, when we check the balance, we are talking to a smart contract. It's different the way it works. So we add and basically it is this contract here that holds all the information about the balance of each account. So I import this token here. It recognizes that it is USDC. It has 6 decimal. I press next. Here he finds that we have 10 USDC because we have sent them with the faucet, and I can import it and I can have it here. So I can import how many tokens. This is ERC-20 tokens, but you can also import NFT or whatever you like. So we have reached the end of the video. I hope that it has been useful, and if you have any questions, please drop a comment below and I will answer you as soon as I can. And thank you for watching, and see you in the next video.